All right, continuing on, we're working through the second page of 6.7, and we're working through the practice problems where we're practicing the graphing method. Graph each one of these lines, look for where they cross, and then we're also talking about the elimination method, doing the solution algebraically. All right, so number 4 is where we left off. To graph these, I like the y equals mx plus b form. That's one method. So this first one, to solve for y, I just need to throw the x across the line, making it a positive 2x and a positive 4 brought down. There's no coefficient in y, so I'm done. I just need to graph slope, which that would be 2 over 1, and that's the y-intercept. That's always the start here point with this method. So starting at the y-intercept is a known point on the y-axis at positive 4, then rise over run from that point. So rising 2, so up 2 over 1, connect those dots, that's that line. Then I do the same thing for the next equation, 4x minus 2y equals negative 8. I'm going to use this method again where I solve for y. So I take the 4x, move the x term, you always take it to the other side. You're trying to get y alone, so the x term needs to move over and switch its sign. Then any constant, just bring it down. You always divide by what's on your variable, so divide by the negative 2, divide this side also by negative 2. Negative 4 divided by negative 2 is positive 2x, and negative 8 over negative 2 is positive 4. So I didn't see it before, but these are just the same lines. So when I graph this, it lies right on top of the other ones. Same-o, same-o. So that's another example. We did one of these earlier where it's a line on top of a line. So the solution is infinite. Infinite solutions there. Now the way that looks if you're doing it by the elimination method, you want to try to add these two lines so that something cancels, either the x's or the y's. I've done the x's on like the last 3 examples. So let's focus on the y's, at least think about the y's. If this were a 2y and that negative 2y, see how that would cancel. So I'm going to take the first equation times it by 2. That makes negative 4x, just doubling everything basically there. And then when I add it to the equation below, the second equation, what happens is when I add, even though I was just focusing on the y's, the x's cancel, the constants cancel. So you just got a big 0 equals 0, and that's how it looks when the lines were the same. That's the way it'll look algebraically. That means a line on top of a line. They were the same line, so all their ratios canceled out when we did the addition method. So infinite solutions is what that means. All right, number 5. Working our way through a lot of examples here, right? I'm starting to think, why did I make so many of these? But it's good practice. Hopefully this is helping you get with this. All right, so something special is going to happen on this one too. And I'm kind of noticing here, if I doubled this and this, those would be the same, but the signs aren't the same there. Anyway, let's look at it on a graph and see what's happening. So by the graphing method, you can point plot, or I tend to like the slope-intercept method. So I would take the x term across the line and make this 3y equals negative 2x and 6. Then divide by 3. Y equals a negative over a positive, so that's negative 2/3 x, and 6 over 3, that's positive 2. So when I graph, I start at 2, start at the y-intercept of 2. Then this is the rise over run. So down 2, since it's negative, 1, 2, and then running positive 3. Connect those dots, that's that first line. Then I'm going to graph the second line. 4x plus 6y equals negative 12. So you're going to solve it for y if you're using that method by throwing the x term across the line, making it negative 4x, and bring down your minus 12. Dividing by 6, we get a similar answer, not the same, but negative 4 over 6 would reduce to negative 2/3. So we do have exactly the same slope, negative 2/3, but then negative 12 over positive 6 makes a negative 2. Let me write that over here where we can see it. So we got a negative 2/3, same slope, but our y-intercept, negative 12 divided by the 6 is negative 2. So it's a different line, but the same slope. So that does graph to be parallel. So when we graph this, we start at -2, and then rise over run, that would be down 2, run 3, and look at that. I can draw it to look parallel. Those are parallel lines. So the solution is where they cross. If they're parallel, meaning having the same slope, but different lines, because they have different y-intercepts, that means they're not going to cross. There's no solution to that, no solution. All right, one more of these. Number 6. All right, so doing each, I forgot to do the second method on that last one. Sorry about that, guys. What happens on the last example, I better write that down. We need to see that. Whenever we add, use the addition method on this example, what happens is, say I multiply that by -2, a lot of things do cancel, but not everything. So when I add the second line to it, here's how it looks. The x's do cancel and so do the y's. So you do get a 0 like on that other special case. But the right side, they don't cancel out, you get some other constant. So you wind up with a false statement. And this has happened to us in the algebra domain when we were solving equations. If you just get a false statement like that, the variables are gone, and just a crazy statement, that means no solution. So that's how it would look like 0 equals something else. Not a true statement, that's the parallel example. All right, last one now. So on this one, I'm going to graph each one. Let's go back to point plotting for you guys that prefer that. Let's make the XY table, maybe pick numbers like 0 and 1. Whatever you like there, but 2 times 0 plus y equals -6 gives me a solution of just y equals -6, so that's 1 point. 1, 2, 3, 4, 5, 6. Another point, I'm going to plug in 1 for x, so 2 times 1 plus y. That's 2. When I throw 2 across the line, it's -2. Oh, my graph doesn't go that far. And when x is 1, y is -8. So over 1 is down 8. Can y'all still see that? Let's plot those and graph that line. Then I'm going to do the same thing for the other line. Plot 2 points. Did I make these parallel again? I think I did, so we get another practice of that. I'm going to plug in 0 and 1. When I plug in 0 for x, 4 times 0 plus 2y equals 8. Solve that, you get y is 4. Then I'm going to plug in x is 1. 4 times 1 plus 2 times what is 8? 4 times 1 is 4. Then throw the 4 across the line, -4. Divide by the 2. Y is 2. All right, let's plot those 2 points. So 0, 1, 2, 3, 4. And over 1, up 2. Again, I'm not using graph paper. It's hard to tell on these, isn't it? Let's see. I think they should be parallel. It looks like they could be, but my graph, like I said, is not super great because I'm not using graph paper. Here's how I'm going to know for sure, though, and it really is probably easier to do it algebraically, I think, than drawing the graphs, is I'm going to use Elimination Method and check it out that way, algebraically. So with the Elimination Method, we need something to disappear here, either the x's or the y's. I'm going to think about the y's, although it doesn't really matter, but if I times this by -2, I'll have a -2y and a +2y, which will cancel out. Now what happens is the x's also cancel out along with it. Leave this one alone. Now when you add, the x's cancel, the y's cancel, and then you've got 20. So that's what I said earlier in the last example that happened too, when you get a false statement, when the x and the y ratios were the same, making the slope the same, but it had a different intercept, a different constant, you get that false statement. So that means they were parallel, so my lines were correct to be parallel, and that means no solution on that. All right, on the next page, page 3, you can see the list of the rules for the elimination method or the addition method. Step 1, The terms need to line up. So if they're not all the examples we did, and I think what you'll see in your homework will all be like this, but just so you know, they would need to be rearranged so the x's line up, the y's line up, and the constant line up, since we're going to do an addition. So rearrange them if you must. Step 2, if necessary, rewrite the equations by multiplying by a constant that creates opposite variables on either of the opposite variable amounts on either. So either the y's are opposites or the x are opposites, and then you have to add the equations so you get a single equation and one variable. And then take that answer, plug it into one of the former equations to find the other part. You know, the solution is an x and a y, the coordinate that solves. And then really should be another step, which is check. See if that answer, I know we did a lot of these that didn't have like a specific answer. I guess 2 of them did. You take that answer, plug it back in the original equations. That's how you're going to check and know if your answer really works. All right, I think I'll pause there and we'll do one more video with the substitution method.